Smart AI Buyer's Guide. Today, we're creating the definitive buyer's guide for building your own AI hardware setup. We'll cut through the hype to focus on what truly matters, getting the most performance for your money. This guide will provide clear, actionable advice for anyone from a hobbyist to a serious developer. The entry ticket. Our journey starts with the most recognizable name in single board computing, the Raspberry Pi. The central question is whether this popular and affordable board can serve as a legitimate starting point for AI. Let's establish a realistic baseline of its cost and capabilities. What is the true cost to get in the game with a Pi 5? A complete Raspberry Pi 5 starter kit with 8 gigabytes of RAM, a 27W power supply, and active cooling will cost between 150 and 180. For that price, the AI power is like having an incredibly fast research assistant. It can't write the paper for you, but it can find and organize all the source material with incredible speed. What can the Pi 5 see on its own, without any help? On its own, the Pi 5 CPU can run a simple mobile net model at a few frames per second, roughly 2 to 5 FPS. This is like a person recognizing the basic outline of an object, but needing a moment to process it. The recognition is there, but it's far from instantaneous. Is the 8 gigabytes RAM model a mandatory upgrade? The 4 gigabytes model is a standard workbench, perfectly adequate for single tasks like a dedicated smart camera. The 8 gigabytes model is a much larger workbench, which becomes essential when you need to handle multiple processes or high-resolution video streams simultaneously. The choice depends entirely on the complexity of your multitasking needs. Choosing your AI superpower. With a baseline established, the next logical step is adding an AI accelerator to boost performance. This is a critical decision that directly impacts your project's power, cost, and software workflow. Let's compare the main options. How do you choose between the main sidekicks, like the Halo, 8L, and Google Coral? The Raspberry Pi AI kit, with its Halo 8L chip, is a specialist, delivering 13 tops of power for about 80. In contrast, the Google Coral USB is a generalist, offering 4 tops for around 95 with broad TensorFlow-like compatibility. It's a choice between raw, specialized power and flexible, widespread usability. Beyond the sticker price, what are the hidden operational costs? Adding an accelerator requires supporting hardware. It's not a simple plug-and-play upgrade. A more powerful 27-watt USB-C power supply is mandatory to meet the increased energy demand. Likewise, an active cooling system is essential to prevent thermal throttling from negating your performance gains. For a specific project, like a smart bird feeder, which accelerator gives the best bang for your buck? For running a YLOV 8N object detection model, the Raspberry Pi AI kit offers superior value. Its higher TOPS rating directly translates to more frames per second for your investment. For this specific use case, the Halo accelerator is the more cost-effective choice for achieving smooth, real-time analysis. The glass ceiling. Adding an accelerator reveals the next layer of system limitations, which is crucial for managing expectations. Raw processing power, measured in TOPS, doesn't guarantee proportional real-world performance. The system's underlying architecture creates bottlenecks that buyers need to understand. You have a 13 TOPS accelerator, so why isn't your Pi a supercomputer? This is due to the shared memory bottleneck, a key architectural constraint. Your 13 TOPS accelerator is a Formula One engine, but it's forced to draw data from the Pi's main ELP-EDDR4X RAM across a narrow bus. The engine has immense power, but it's constantly waiting for fuel because the delivery route can't keep up. What AI dreams can a maxed out Pi realistically achieve? A Pi with an accelerator excels at running optimized models like YOLOv8N for object detection or FastSCNN for segmentation. However, attempting to run large generative models like Stable Diffusion is fundamentally impractical. The memory and bandwidth requirements of such models are far beyond what this hardware architecture can provide. How much faster is a supercharged Pi in reality? The real-world performance gain is significant and immediately noticeable. You go from a sluggish 2 to 3 FPS on the CPU to 30, 60, or even 100 FPS with an accelerator. It's the difference between watching a choppy slideshow and a perfectly fluid video feed. The professional tier. Now we move to the next tier of hardware, the NVIDIA Jetson family. This represents a shift from general-purpose computing with add-ons to a purpose-built, integrated AI platform. This changes the conversation from what is possible to what is optimal for a product. What does the leap from a maxed-out Pi to a Jetson Orin feel like, both in power and price? The performance leap from a Pi to a Jetson Orin is like moving from a tuned-up streetcar to a purpose-built Formula One machine. In terms of cost, a full Pi setup is under $200, whereas a Jetson Orin Nano developer kit with necessary peripherals will cost closer to $500. This price difference reflects a significant step up in integrated engineering and software maturity. How does the Jetson's performance per watt change the game for mobile projects? The Jetson Orin Nano's typical power draw of 7 to 15 watts is a critical feature for any mobile or battery-powered application. Its high performance per watt means it can perform complex AI tasks for longer periods on a limited power budget. This efficiency is a core part of its value proposition for edge computing. How much real-world time does native PyTorch support save a developer? Native PyTorch support on Jetson eliminates the need for model conversion, a process that can take days of debugging. This is like being a native speaker versus using a translation dictionary. It allows developers to deploy their models directly and iterate much faster. The time saved represents a significant reduction in development cost and effort. Is the Jetson's LPDR5 RAM a noticeable upgrade? Yes, the LPDR5 RAM on a Jetson provides a major advantage. Its higher memory bandwidth acts like a wider highway, allowing more data to be fed to the processor, which is crucial for high-resolution video or complex models. It directly addresses the bottleneck that limits the performance of add-on accelerators on other platforms. The creator's dilemma. The next logical step for many is AI training, teaching a model to recognize new things. The question is what is realistically achievable without relying on expensive cloud services. Let's look at the most cost-effective paths to creating your own custom models. What are the true training limits of a Jetson Orin? A Jetson Orin is capable of transfer learning. It can be taught to recognize new objects by fine-tuning a model like YOLOv8S on a custom dataset. This process, however, is still time-intensive, often taking several hours per training epoch. It's suitable for specialization, not for training a large, complex model from scratch. How does a 350 used RTX 3060 change your training capabilities? A used 350 RTX 3060 with 12 gigabytes of VRAM completely changes the training equation. It offers an order of magnitude increase in training speed compared to an embedded device like a Jetson. For anyone serious about custom model development, a budget desktop GPU provides a far more efficient workflow. Is renting a GPU in the cloud a smart alternative? Renting a GPU in the cloud via a service like Google Colab Pro is a highly effective strategy for short-term, intensive training tasks. It provides access to high-end hardware on a pay-as-you-go basis, which can be more economical than a large hardware purchase. However, for continuous development, the recurring subscription costs will eventually outweigh the one-time cost of owning the hardware. Final recommendations. With all this information, we can now define clear hardware paths for different users. There is no single best setup, only the right tool for your specific goal and budget. Here are three distinct, actionable recommendations. For the curious hobbyist with 150, what is the smartest possible setup? For a hobbyist on a 150 budget, a Raspberry Pi 5 with 4 gigabytes of RAM, a 27W power supply, and an active cooling case is the most logical starting point. This setup is perfect for learning the fundamentals of edge AI and running lightweight models without overspending. It offers the full Pi 5 experience and a clear path for future upgrades. For the serious prototyper with a 300 budget, what configuration offers the most reliable power? For a prototyper with a budget around 300, the optimal setup is a Raspberry Pi 5 8 GB model combined with a Raspberry Pi AI kit. This configuration provides a powerful, cost-effective platform for developing and testing real-time applications. It hits the sweet spot between price and performance for serious project development. For the aspiring entrepreneur building a product, what is a robust and scalable starting point? For an entrepreneur building a scalable product, the NVIDIA Jetson or a Nano Developer Kit is the recommended entry point, costing around $500. The higher price buys into a professional ecosystem with mature software, greater efficiency, and a direct path to more powerful, deployment-ready modules. It's an investment in stability and faster time to market. What is the one question every buyer must answer before spending a single euro? The most important question is to define your primary goal before you buy anything. Are you learning, building a specific product, or do you need a flexible platform for experimentation? Your answer determines which hardware path is the right investment for you.